Now let us look at the next problem. The figure shows an experimental plot of discharging of a capacitor in an RC circuit. The time constant tau of this circuit lies between. Okay. Now we are given the range in the options, and based on the plot that is shown here, we have to find out what is the time constant. Okay. So we have a resistor, a capacitor. Capacitor is initially charged to Q0 and then connected across a resistor. After some time t, charge drops to Q. Okay. Now when this happens, the drop in the charge as well as the potential is exponential, which is also shown in the plot. Okay, where Q is given by Q0 e to the power minus t by RC, and V0, V is equal to V0 e to the power minus t by RC. Now this problem can be done in two ways. If we know the definition of time constant, in one time constant, that is tau, which is actually equal to RC, in one time constant the potential drops to 63% of its initial value. Sorry, it drops by 63% of its initial value. Okay, so what is the initial value? It is 25, and it drops by 63%. That means 37% is left. So 37% of V0 is somewhere equal to 9 point something. Okay, which is less than 10. So here in the plot you can see, if you take the value of V, which is 9 point something, this value, and if you take the value of time, this time is somewhere between 100 and 150. So the correct option is option D. Now alternatively, we can also do this using the formula, that is V equal to V0 e to the power minus t by tau. Okay. Now we know that t half, that is in half the time, the value of V will become V0 by 2. That is, initially it was 25, now it will become 12.5. And if we see that time will come 100 seconds. Okay. Therefore the value of tau is given by t half divided by log 2, which is 0.693. So if you substitute the values of t half, it is 100 divided by 0.693. Now from simple mathematics we know that this value will be definitely more than 100 but less than 150. Okay, so the correct option is D. So there are two methods of solving this.